I am sure that many of us in this room either suffer from or know someone who suffers from migraine. In fact, over 10% of the global population experiences migraine, and it is the second leading cause of disability worldwide. Migraine is so much more than just a bad headache. Alongside the debilitating head pain, patients also experience a variety of sensory sensitivities that are extremely disabling. For example, during an attack, patients often have to go in a dark room because they find normal levels of light bothersome and can even worsen their head pain. Even the feeling of clothes on your skin or the simple act of brushing your hair can be perceived as painful. Current treatments for migraine are only effective for around half of patients who take them. Interestingly, women are affected by migraine at a higher rate compared to men, about 3 to 1, and the reasons why are not fully understood. Clearly, there is an unmet need for new treatment options for migraine. One potential option could be to develop personalized therapeutics based on sex to provide relief to the undertreated population. My hypothesis is that differences in specific brain circuits of migraine could drive the sex bias for this disease. My research aims to manipulate brain circuit activity and study whether the effects are sex-dependent. Mice represent a really good model for migraine in humans. They exhibit very similar symptoms, including the sensitivities to things like light and touch. Our lab can employ a variety of techniques to manipulate brain circuit activity in mice and study how it affects their migraine-like symptoms. I want us to take a step back and think of the brain like the infamous London Tube map. We can think of the different brain regions as stations on the underground, and these stations are talking to each other via trains on the tracks. During a migraine, what we think is happening is that there's an increase in activity at certain stations. More trains are stopping at them and traveling along the respective tracks. We think that this confers an increased sensitivity to your normal environment. In mice, we can mimic this migraine-like state by manually increasing circuit activity and studying the effects on their migraine-like behaviors. My research has shown that increasing activity of specific brain circuits confers an increased sensitivity in female mice only. For example, the circuit between the cerebellum, the thalamus, and the cortex confers an increased sensitivity to light in female mice only. This suggests changes in specific circuit activity could drive the female dominance in migraine affliction. Mapping the brain circuits of migraine gives us the unique opportunity to develop personalized treatments for this debilitating disease. Thank you.